Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Irfan bin Sharif. My metric number is DE220201. So I want to explain about introduction for our project. So this project aims to provide hands-on experience in power electronics through a project-oriented problem-based learning approach. The objective is to design and simulate a DC to AC conversion system for an RL load using modern tools, bridging the gap between theory and practical application. The system must handle up to 1000 VDC input and varying load condition while ensuring compliance with Malaysian electrical standards, including a total harmonic distortion (HD) limit of 5 to 9%. The project allows students to explore different DC to AC topologies such as SPWM, TPWM, and modified PWM, optimizing efficiency and performance. By reducing harmonic distortion and improving output quality, students gain critical skill in designing reliable and high-performance power electronic system for a particular application. This project enhances their technical knowledge, problem-solving abilities, and real-world readiness in power system design.
Hi, Assalamualaikum. My name is Nur Syamim binti Hussein. My number metric is DE220040. I am from Group 3. So today I will present about the design. So this is the Spwm single phase full bridge inverter with LC filter. So the parameter is set in the simulation is for the VDC, which is 269 volt, and then the resistor is 14 ohm, inductor 0.3 millihenry, and the frequency for this system is 50 Hz.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fadil. So my part is about the simulation. Okay, as you can see here, this is a circuit for the SPWM single phase full bridge with the LC filter. Before we run the circuit, we must input the value for the DC, which is 269 volt. And for the filter, the value for the inductance is 31 exponent negative 4. The capacitance is 0.9 exponent negative 6. For the load, the resistance value is 14, and for the inductance 0.3 exponent negative 3. For the sine wave, amplitude is 1, frequency 2580 Hz, and sample time 1/10,000. So we run. As you can see here, there are 3 output waveform. The first one is for the voltage input waveform, current output waveform, and voltage output waveform. For the voltage input, the value is 269 volt, and for the current is 60.89 ampere, and for the voltage output is 240.8 volt. So next we see the VHD value. So for the VHD value, if I 0.2, number cycle 2, let's see the 15. For the VHD value for the current output is 5.27%. So the voltage output for the VHD value for the voltage output is 8.86%. So for the volts, VHD value for the current and voltage output is still in the range that has been stated in the bit. So that's all for me. Thank you.
For the manual calculation, by using the parameter set in the simulation, we need to find the value for 9 harmonic. In the table, we can find the value for Zn, theta n, In, and Vn by using the formula. Then we can find the value for n omega t, which is we get 314 NT. For the instantaneous load current, the formula is In sin n omega t minus theta n. So we know fundamental load current is 24.46 ampere. Then to find the RMS load current at fundamental frequency, the peak fundamental load current divide by square root 2, and we get 17.3 ampere. Then we consider up to non-harmonic, the peak load current is 26.47. Next, the RMS harmonic load current, by using the formula, we get 1.4213 ampere. For THD before filter at load current, by using the formula, we get 41.36%. And the THD of load voltage before filter, we get 48.40%.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hamzah Syamil bin Awazaki. Manometrik DE210041. Okay, for the part of methodology has consists a flowchart. Okay, the flowchart is start with designing and set up a parameter of the SPWM circuit to generate variable with pulse based on a sinusoidal reference wave. Okay, which is control the full bridge inverter. The second step is design a single phase full bridge inverter with AC filter. This design has a using for MOSFET that convert the voltage DC up to 1000 VDC into an AC pass form. with Spwm ensuring coordinated switching to create a basic AC waveform. Okay, the next step is manual calculation and set up a parameter of LC filter, which is the value of inductor and capacitor. After make a calculation, is 31 millihenry and 0.9 microfarad. The purpose of LC filter is to filter the high harmonic and producing a smooth sinusoidal output. By the way, a 14 ohm resistor serves as the load or RL load to simulate the real condition. Okay, the next is run simulation. The system is simulated in MATLAB Simulate using the power gate blocks to solve equation and analyze harmonic via FFT. Okay, the output waveform and total harmonic distortion THD values are recorded and checked to ensure they fall within the 5% to 9% range. Adjustments are made if necessary, and the process repeat until the design meets all the specification. Okay, the next we go through the discussion. Okay, for the discussion, the main objective for this project is to convert DC input to AC output with THD value between 5% to 9%. And we can see the figure of the figure at the top shows the waveform sinusoidal that has reached the value of voltage output. While the figure at the bottom shows the waveform sinusoidal of the current output at approximately 60.89 ampere. Okay, the next discussion, we go through the each one.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzahan bin Marjahan and my metric number is DE220147. Now I will explain about the FFT analysis for this project. So the first one, I will explain about the FFT analysis for the voltage input. As the figure shown in this slide, it can be noticed that there is very dominant amplitude of 269 volt at the fundamental frequency of the input voltage. It gives a representation of the major strengths of the signal and will in general be the most significant element of the frequency in the FFT spectrum. Any other peaks in the spectrum would likely to be due to harmonics or signal distortion, while the base level of the noise floor would indicate interference in the background that can be potentially debilitating to the general quality of the signal. This breakdown is important in a depth examination into the quality and behavior of the voltage input. It follows, therefore, that such analysis may be employed and as identification of potential harmonic distortion problems or even increased noise, all of which are obstacles to the proper performance of the systems. Now I will explain about the FFT analysis of current output. As figure shown in this slide, the FFT analysis of the current waveform that will provide a better view of the harmonic content and its behavior in the frequency domain. Distinctly shown in this graph is a peak at a frequency of 50 Hz that is a fundamental frequency or the desired sinusoidal current, and other peaks corresponding to the harmonic frequencies. As a result of a distortion in the waveform, these harmonic peaks are relatively small in the magnitude and reflect the capability of the system in terms of current distortion, which must be an effect of the principle applied the sinusoidal pulse width modulation strategy along with the filtering stage. Another important quantitative indication of the purity of the waveform of the current is the value of THD, where the obtained from the FFT analysis is 5.27% in above format relative to fundamental frequency. Lower values of the THD mean higher quality power, which is imperative for the normal functioning of sensitive load and also very crucial to satisfy the most stringent requirement laid down by the grid compliant. This result confirms that the inverter works fine, operating an almost sinusoidal current waveform to supply it. Now I will continue for the FFT analysis of voltage output. As figure shown in this slide, it follows from the analysis that the 50 Hz fundamental frequency will prevail in the spectrum while all higher order harmonics are drastically damped due to the introduction of filtering component in the system. Besides that, the obtained voltage waveform also provides a result in the calculation of THD as 8.86%, which is a calculator for comparison to the benchmark standard to assess the general performance of the system. This is a fairly clean spectrum with a less harmonic distortion. Will go to show that the capacitor filter does a good job suppressing most of the high frequency noise to maintain a steadier output voltage. This deep analysis of the spectral characteristic will point out not only the performance of the system but also prove quite well how much a design is meeting application-specific requirements such as compatibility with sensitive equipment or for the passing relevant grade regulation. And lastly, for the part discussion, which is the duty cycle waveform. As the figure shown in the slide, the graph of the duty cycle waveform in the Spwm system, which give a fair description of how the modulation in Spwm varies the pulse width of the switching signals over time to simulate the sinusoidal reference signal. Hence, the output of the inverter will follow the desired waveform quite closely. The variation of this duty cycle should be very accurate for accurate modulation and to reduce harmonic distortion in the output waveform. It highlights how many change in switching frequency or modulation index could be impactful regarding the pattern of the duty cycle, which such factor inherently affect the inverter performance and consequently the AC waveform to be generated. This waveform therefore becomes a witness to the success of Spwm in supplying high fidelity AC power with efficiency and stability across a wide operation range.
So at the end of the project, so for the conclusion, simulation result confirm that the system convert a DC input of 269 volt to a stable AC output voltage of 240.8 volt with a current output of 16.89 ampere. The FFT analysis further validated the inverter's performance, showing a THD of 5.27% for the current and 8.86% for the voltage output. So we're meeting power quality standards. And overall, this project highlights the effectiveness of combining Spwm with an NFC filter to achieve high quality AC power output in power electronic system. The result demonstrates that this approach is suitable for various practical applications, including renewable energy system and standalone AC loads. So for the future improvement, may focus on optimizing the inverter's design by exploring advanced filtering techniques and control algorithm to further reduce THD and enhance performance. So that's all from me. Thank you.